Namaskar. Hello everyone. RVD here and a very warm welcome to my YouTube channel. In today's video, we will be writing a program for finding the roots of quadratic equation. See, in my previous video, I've already spent a complete one video for explaining what is quadratic equation, how do we accept the inputs in what form, and what are the different types of roots that we can get, and what are the formulae for that. So if you have not watched that video, I would advise you to first go and watch that video so that this particular video of implementing this program would be easier for you to understand. Okay, before I go ahead, a sincere request to all of you, do subscribe my channel if you are not yet subscribed, and do spread it across to your friends. You can even share all my videos, like them, comment on those videos so that I'll be able to understand the feedback and I'll be able to improve accordingly. You can also follow me on Facebook. You can obviously search me with my same name as my channel name, and even on Instagram and Twitter. So let us continue with this particular video. In this video, I'll be implementing the program of roots of quadratic equation. One of the very important program, a good example for having an if-else ladder, and lot of things, lot of concepts we'll be using in this. Okay, so we would be accepting the quadratic equation with the help of its coefficient, like ax square plus bx plus c form. So ABC will be taken. First we'll check whether it's a quadratic equation or not, and then if it is a quadratic equation, we would be finding the roots along with the type of roots. Okay, so I'll be taking A, B, C. For simplicity, we assume that it will be integers. You can even take them as double or float. Okay, or maybe I can take them as float only, so that even if you want to have them integer, you can have it as integer. If you want to have them as fractions, even that will be allowed. Along with that, I would need one D, which is going to store the value of delta, that is b square minus 4ac. So the first thing I do is I ask for the coefficient. So enter coefficient of, I'll put it in short, you can write a complete version of that, quadratic equation. Okay, so that will be taken as, because I've taken them as float now. Okay, so I got ABC. Okay, that will be read. Now the first check that I can do is if A is equal to 0. Now you know that ax square plus bx plus c happens to be a quadratic equation only when the degree of that equation is 2. That means my value of A, which is a coefficient of x square, should not be 0. So if A is 0, I would simply print, okay, not a quadratic equation, and I can straight away return. Even though the return type is void, it doesn't stop me from returning back to the system. So when I say return, I'm not going to return any value, but I'm simply saying return. So if A is 0, just print it's not a quadratic equation, and return will halt the program. It will come out of the main function. So the remaining program is as good as in else part, even though we haven't written it. I hope you understood this. So now when you go down, we are very sure that it's a quadratic equation. So I'll first calculate the value of delta, that is b square minus 4 into a into c. Okay, now my types of roots, it depends on the value of d. Okay, for storing the roots, I would require maybe two variables, so I can even create them. Let me put them as x1 and x2 for simplicity. So we start with if d is greater than 0. Let me have the complete skeleton ready so you'll get it properly. So if d is greater than 0, that means d is positive. My roots are real and distinct. Okay, so that means I'll have two different roots, root 1 and root 2. Okay, in else part, first I said I'll be making the skeleton ready. If d is less than 0, then in that case the roots are complex, and actually they are complex conjugate, but even if I write complex, I guess that should be sufficient. Okay, now along with that we will have one more case where the value of d would be equal to 0. So I would simply put it in else part. I don't have to check that, because if d is not greater than 0, if it is not less than 0, then it's going to be equal to 0. Now, if the value of d is equal to 0, it means roots are real and equal. Okay, yes. So now the skeleton is ready. Now we need to put in the logic for finding the roots for each of the case, and then the program will be ready. So if the roots are real and distinct, my roots are going to be minus b plus square root of b square minus 4ac, that is square root of d upon 2a. And the other one is going to be simply minus of that. So minus b plus root d minus b minus root d. So what is x1? It is minus b plus sqrt of d, the whole bracket. The whole bracket is required because we want the complete numerator to be divided by 2 into a. Okay, get that clearly. So this is the first root. Similarly, I'll have a second root, which is minus b plus sqrt, minus b minus sqrt of d upon 2 into a. Okay, so minus b plus square root of d upon 2a is my root 1, and minus b minus square root of d upon 2a is the second root. Okay, so I'll be printing the roots. So printf root 1. Okay, it's going to be again a fraction, so I can use 0.2f. If you're wondering what is %.2f, it's something called as precision. Okay, you can very well check my previous videos in the same list where I've talked about fill width, flags, precisions, everything with examples. Okay, so root 1 is going to be x1. Similarly, I'll be having root 2. Okay, %.2f, and that will be x2. So this part is done. Now I'm coming to the complex part. See here, roots are complex conjugate. So if the first one is a plus ib, the second one is a minus ib. Now I cannot calculate the imaginary part. So what do? I calculate the real part. So I'll be using x1 here to store the real part, and x2 here to store the imaginary part, or to be very precise, real part of the imaginary part. Okay, again I already said that in the previous video I had explained it everything. So if you see that video, this becomes very easy to grasp. So my x1 would be minus b upon 2 into a, which has to be in bracket. Okay, so that's the real part, minus b upon 2a. The imaginary part is square root of d upon 2a, but d is negative, so I'll take that minus away, which will be square root of minus 1, and that will be printed as I. So that's the reason I would be saying sqrt of minus d, okay, upon 2a. So don't get surprised with that minus d. Remember, we are under the case where d is negative, so minus d has to be positive. Okay, so I'll be printing the first root. Now see how exactly I'm printing the roots. Root 1 would be the real part, %.2f, okay, plus the imaginary part, %.2f slash n. The real part I would say x1, and the imaginary part I can say fabs of x2. Now remember, I don't want the sign of x2, because even if my x2 happens to be, let's say, minus 5, because maybe the value of a happens to be 0, I would still take that value as 5 because I am finally going to print one with the positive, one with the negative. So imagine if my real part is 2 and the imaginary part is -5, I'll take only 2 and 5 so that I can print them as 2 plus 5i and 2 minus 5i. Okay, my mistake, I haven't printed I here, so I have to print I. Okay, so you would see how exactly it gets printed finally in the output. So similarly, I would print the second root, root 2 equal to %.2f. Now here I'm not going to print that negative sign. You try to understand why, because see, for positive you don't get sign, so we have to print plus. For negative, okay, but then I have taken the absolute value, so I'll be obviously printing that minus also, and I'll be still printing the argument as absolute, so I will not have any problem of sign. Okay, so this should do the job for complex. Now the last part, that is real and equal, which is very simple. I can simply use x1. Now you can see b is 0, so I simply have minus b upon 2 into a as a single root. So I'm not going to print them as root 1, root 2 and all. I would simply say root equal to %.2f, and it will simply be printed as x1. That's it. Okay, we've already had spent enough time here, so I'll quickly run and let us check with at least 3 cases so that you'll be able to see that each of the case runs properly. Okay, it's going to be a bigger video, but I hope you will bear with me for that because it's one of the very important questions that I'm taking. So let me save it. Let us compile. Let me see if there are any errors. Okay, I have sqrt, but I haven't included mat.h. Okay, that's a good thing. You have to include mat.h, so you won't be able to see those warnings as well. Let us compile. Yeah, it gets compiled properly now, and let me execute. So let us have x minus 2 the whole square. Now x minus 2 the whole square, the root is going to be real and equal, and x is equal to 2. So for x minus 2 the whole square, it is x square minus 4x plus 4. So x square minus 4x plus 4. Yes, roots are real and equal. Okay, and root is equal to 2. Perfect. Let us run it one more time. So let me have it as, let's say, x minus 3, x plus 7. So x square plus 4x minus 21. So x minus 3, that means root will be plus 3 and minus 7. Okay, I hope you're getting it. Going a bit fast, so maybe you can lower down the speed while listening to this, understand, take it down on a paper, and then check whether we are doing it properly. So x square, that is 1, plus 4x and minus 21. You can see roots are real and distinct. Perfect. Root 1 is 3, root 2 is minus 7. That's what I just now said. I also know one simple case for getting complex, that is 1, 2, 3. With that I'll be getting root 2, which will be 1.41. So I guess it is minus 1 plus root 2i minus 1 minus root 2i, if I'm not wrong. Let us check. Yeah, root 1 is minus. Now see the way very beautifully that output is getting displayed. Minus 1 plus 1.41i and minus 1 minus 1.41i. They are complex conjugate of each other. Okay, that's it. That's a wonderful concept of finding the roots of quadratic equation. I'll be just quickly scrolling down it a bit slow so that it will get captured in my video. So if at all you feel like doing it yourself, you can pause it. You can very well try to do it so that you'll be able to get a complete idea about how quadratic equations can be solved with the help of a C program. So you can see complete the initial part is available where I'm taking the coefficients, checking whether it's a quadratic equation. I haven't shown you that case, but that's very simple. If at all I give the value of a is 0, it will immediately come out saying that not a quadratic equation. Okay. Otherwise, we calculate D. Based on D, we have 3 different types. If D is positive, roots are real and distinct. If it is negative, roots are complex. And if it is not, that is, if it is 0, if both of them are false, then it is 0, then the roots are real and equal. Okay, that's it. So without further delaying, let me conclude with this video. Okay, thanks a lot for watching, and as usual, happy learning.